almost everybody who's using machine learning in industry these days is doing what we call in the field supervised learning. And so the standard paradigm is that there is a data set given to you, such as a bunch of handwritten digits with labels on them. So this is a 4, this is a 3, this is a 1. You'd have many other examples of 4s and 3s and 1s and 8s. And then you're given a new image and you have to say which one is it. And that's sort of a simple task. You could also have just pictures, and this one has a pedestrian, that one doesn't have a pedestrian. You have a labeled data set, and you have to learn a function that given an unseen instance predicts what the label is going to be. Now, this is a fairly mature area. There are toolkits, and there's been, Weka is an open source toolkit that's been around for a long time that has a lot of different machine learning algorithms. Now everybody's using neural networks and deep neural networks, and there's a lot of toolkits, put out by many different companies for doing exactly problems like this, supervised learning. So in some sense, you don't need to be an expert in machine learning, or even have really great programming skills to be able to use supervised learning. And so that's why it's sort of the popular paradigm. But for autonomous agents, for the goal of my research of creating fully autonomous agents, reinforcement learning is a much more appropriate paradigm. And the basic way is, rather than being given a batch of data with labels on it, instead you have an agent that's interacting over and over again with its environment. It's taking an action according to some policy, where the policy is a mapping from state to action. So you can think of the state as being maybe the position of the chessboard, or where you are on the road, where your autonomous car is on the road and what it's sensing. And an action could be where to move the chess piece, or whether to turn right or left, right? And you need a policy. From every state, there should be some action you take. And then after you take the action, that gets sent to the environment. And in response, you get a reward, maybe how much gas was used, or how long it took to get to the next intersection. And you find yourself at the next state. And you have to then take another action, and you just interact in this closed loop. And the goal of reinforcement learning is to find the optimal policy, to find the policy that, if you act according to it, gives you the highest reward over time. And so, and I guess, just to put it in concrete terms, an example I like to give is, if you're a web advertiser, the supervised learning question would be, if on a particular web page I put this ad, will Peter click on it or not? So you could ask the question, will I click on that ad? You have a lot of different past websites I've looked at, and you have examples of ads that I did click on and haven't clicked on. That's the labeled data set. You could do supervised learning. The reinforcement learning question would be, what if I show Peter this ad today, and he doesn't click on it, but then I show him another ad tomorrow and he still doesn't click on it, and 3 days later he clicks on, I show another ad and he does click on it. Now the question is, what was the effect of that sequence of actions, right? It's not just that the last ad was a success and the other ones were failures. Maybe those ones set me up to want to click on the one 3 days later. And that's what, it's this sequential aspect, this effects of actions and sequential actions that reinforcement learning gets at. And there's really two main differences from supervised learning, the biggest differences. One are that you don't have there's this time delay between the reward. So you have to take a sequence of actions, and then you get a reward, and you need to go back and figure out what led to that. And then the other is that you're not given a batch of data. The algorithm itself is responsible for gathering its own data. If you make the same chess moves every single time, you'll never learn about what would have happened had you taken another one. Or if you drive the same route to work, you'll never learn about what happens if you take the other routes. So that's what the kinds of questions that reinforcement learning gets at that supervised learning doesn't. Reinforcement learning can be formalized as what's known as a Markov decision process. So it's got components of states shown in green here. And from every state, there's some actions you can take. So from this S0, you can take A0 or A1. And then they may have probabilistic effects. So if you take A0, there's a 50% chance it'll end you back at S0, or a 50% chance it'll end you at S2. And then sometimes there are these sort of rewards emanating. And the goal is to find the policy that, if you act according to it, for every state you take that action, will give you the highest reward over time.